So, hello everyone. I'm more than happy to be here. I'm Stéphane Poufari from Energy 2050. I'm a member of HESTIA consortium, and today we are more than proud to share this second workshop with three very interesting projects, so HESTIA, Sander, and AXPO, and we will have opportunity to discuss on a small, let's say, selection of innovation which can be helpful to be duplicated and scale up at the EU level to support the implementation and let's say, development of energy community. So, it's not a very big issue, but I'm the CEO of Energy 2050, that's it. Okay, so as I was saying, we will have a selection. About innovation, I don't want to recall everything because everybody here is a professional and know, I'm sure fully, all the concern, barriers, challenge we need to face to design and scale up energy community at EU level. But having said that, and it was also part of the discussion in the previous session, when we spoke about KPIs, EC evaluation, and all the concern, it is also research projects. So what does it mean? It means that we create part of puzzle, which are complex. And if we take all, let's say, these single elements, we can find solution, but as soon as we bridge with some other ones, dealing with behavioral change, with technology concerns, with grid concerns, with regulatory frameworks, everything gets more complex. And at the end, I remember one word, which is flexibility. And here we just think about a new paradigm on energy, let's say, production and consumption. And it is a huge challenge, because for me, we are doing this activity since decades. If we succeed on energy community somewhere, we will succeed to change the global energy process. Because normally, when we design, we think about energy community, we have to think about both demand and also production. And many guys just focus on one or on the other. But if we mix two, which means flexibility, capacity of integration, different vectors, different energy, everything, if we succeed here, it means we have a chance to organize a very decentralized energy patterns everywhere. And even now, we are pushing this kind of projects abroad, in Africa, for example, when they are really lacking of any legal frameworks, and even sometimes to produce on the grid about renewables. Why? Because they are communities by nature, and here this solution, every solution we create here can make sense to design a new approach. So it's so important that we need to think about this innovation as part of a puzzle, not the ending solution. It's too complex. But we need also all the times to reconnect with the policy consideration to make the change. So I will skip here my, let's say, small, very short introduction, by the way. And I will go directly to the first speaker. So we will have 3 speakers from each of the one projects. They will have 10 minutes to present some insight from the project. That's it. We have many, many of them. Please visit the website. They are very fabulous projects. And after, we will have a video also, a kind of testimony about the pilots, which are very important. This is also part of the discussion of the previous one. Pilots are facing the real world. And for me, even if we have sometimes locking effect, bad solution is not working, for me it's very relevant. Why? Because it explains how we can anticipate and go beyond in the next steps. And when we will go for that in a larger scale, we need this blocking effect, which have been understood, to go beyond. So we will have pilots. It will be a very short video, 8 minutes. And after, we will have a series of question and answer from the, let's say, speakers. I will ask questions. And after, from you. And also, I will say online if we have some. Okay, so my friend Francesco, it's your time. And you have 10 minutes.
Thank you very much. I have to update my photo because it's 20 years ago, maybe. But, okay, okay, it's good, but 20 years ago. I will speak about HESTIA, and I'm very glad to do it because it was a great consortium work. HESTIA is, I think that this morning has already been discussed, but HESTIA is an EU-funded project, and the aim of HESTIA was to develop solutions, in particular for demanded response services. and in general solutions that will be cost effective but also socially acceptable. The 4 pillars from the beginning of HESTIA was to develop, as I said, demand response cost-effective solution, because demand response, as Stefan said, is a revolution in the energy paradigm. So demand response means that each one of us in our household can contribute to the grid, to the stability of the grid, and to the energy world. But it has to be cost-effective, because it's not an industrial cost. You have to have costs that are sustainable to develop solution in each of one of our households. The environmental impact, because all activities in HESTIA were done in order to promote the use of renewable energy, where possible PV plants, and in general to make positive environmental impact, reducing energy consumption or shifting energy consumption in good time, depending on the nation, depending on regulation, depending on the grid status. The economical benefits, because at the end, an economical benefit may be minimum, but has to be granted to make the change. And also the demand response is a theme that is incentivized in these months and years in all across Europe. So we have to check also to start up this kind of activities an economical benefit. And in general, the main economical benefits will be to reduce the energy consumption, even if it's not the only KPI to be seen, because it's very, 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 it's important, but not all the energy consumption from the grid. About the fourth pillar was about technological advancement, in particular to use ICT tools to monitor, to make predictive analytics, and to develop some automated decision. So to bring the up-to-date technological point of view in of each households in the pilots. As I said, so the first part was to make an ICT integration, because we were a lot of members of the consortium, different technology, different nations, so we have at first to equalize what was best in our solution, best in our nation, best in our technology, and then try to implement it depending on the pilot, depending on the case. The user-centric approach this morning, I don't want to speak too much, because this morning was very interesting about, okay, we should have always a user-centric approach. We try to do it in HESTIA, but we could be more effective, have to be said. All have to start from the user if we want to change the energy paradigm, as Stefan said. For this reason, there were 3 pilots in Italy, in France, and the Netherlands, and we started also to engage the people in these 3 pilots in the early stage of the project. Remuneration. The solution provided by HESTIA has a remuneration module. Remuneration connected to the demand response action that are central in this view. We have to say that it was tested in a theoretical way. The people were not physically remunerated, but the tool is is ready, and in the Italian pilot it was tested. About environmental and economic benefits, we can say that, okay, we promote the use of renewable energy, in particular PV plants. In many parts of the pilots were already present, but not always well used, or there were not the storage system. So we added the storage system, for example, in the Italian pilot. And so we can promote the renewable energy and the conscious use of renewable energy, and in general, optimizing the consumption, the time of the consumption, we made incremental other environmental benefits. One of the pillars of the project is to share these 2 words about social and technological sides, and each one has to speak with the other to guarantee that this solution will be implemented or will be effective. So, as I said before, in the early stage of the project, people were involved. It was a little bit hard to keep people interested for years and years, because HESTIA project lasts at the length or forecasted length of 3 years, and will last 4 years because of the COVID period that was very, very hard for pilot implementation. So it was very, very, very difficult and not always the best to keep the people engaged for 4 years. About the pilots, we can say, okay, as I said before, and as it was said, there were a pilot in Italy, in Berchidda. The municipality of Berchidda owns their distribution grid, so it was a little bit more easy to develop demand response in this kind of sandbox. Camille Claudel in France, a big eco-district, and with an attention to shift the consumption during out of the peak of the problem of the energy grid in France. So this was the main challenge of this pilot. And Voorhout in the Netherlands with second life batteries storage, EV, electrical vehicles storage batteries that was used for storage in the households, so a second life project. And also the demand response arbitrage was thought about this pilot. This is a summary, graphical summary of HESTIA services. Just in summary, in orange color, there are all the demand response services of the solution. In green, there are all the behavioral side of the solution. And in yellow, there is the blockchain platform for the demand response. So it's an integrated solution with several boxes and parts that have to be integrated. As I said, a little bit more in deep, these are use cases. So what was really done in the pilot? In the Italian pilot, there was a shifting in electricity use to favorable moments and according to PV production, and also improved the management of the storage system that was manual, so it was not automatic, but it was improved the sensibility of the people to use it in a more active way. The Dutch pilot was used also to test the arbitrage, so basically to absorb from the grid in a certain period, absorb from the grid in a certain period and to release in a more favorable period, and maximize the self-consumption in the Dutch pilot. Also, the French pilot, as I said before, it was to shift the consumption out of this time frame that are very critical for France grid. As I said, there is a remuneration model that is an innovative thing. It was not practically tested, but it's in place and it's affordable according to our idea. And the HESTIA platform, here you find some graphic, but basically there are the dashboard, the daily consumption and production, the flows of the energy, and the gamification module that this morning maybe we discovered that it's not very appreciated from the people. Okay, we'll take note, and it will be another information to develop a more efficient solution. Results. There were a lot of KPIs, but among the others, there was a 10% mean reduction in the consumption for the grid, more than 50% increase in self-consumption in the Italian pilot because of the storage system, as I said before, and more than 20% overall consumption reduction for the Dutch pilot, for the sensibility to have data and can check our consumption. User engagement, up left, you find the users with more than 20 access to the platform, and that are the one that has more self-consumption and less grid import. So there is a connection between the access and the positive KPIs. Conclusions. In general, we can do some more. We can refine the model, refine the solution according to the feedback from the pilots, And from the KPIs that were a lot, 50, a lot of them are not calculable in this moment, so there is another something to be checked, but in the main KPIs that are grid consumption, but not only this, the usage of the platform, the involvement of people, there are a lot of good feedback that will be implemented maybe in a future activity of the consortium after the conclusion of the EU-funded project. Sorry.
More than perfect, and you are right on time.
You were very timely to say, okay, yes. 2 minutes.
I'm so sorry for that. The timekeeper
no.
is a bad
word. You have to.
So maybe we will jump directly with a colleague from Sander. And so like that, we will have the question after the 3 presentation. So I will make some sign about the time sometimes.
Yeah, good morning. Thank you very much for having me here. And as Stefan said, I represent the Sender project, and we had the first session on it from Agnol this morning. And I think I'll partly come back to what he said. So what was the application concept and objectives that we outlined for the project? We said that Sender will develop energy service applications for demand response, but also for home automation, convenience, and security mechanisms. So not only, let's say, one stop for demand response, but also sensors to offer additional household-related services to consumers. We also said that we will apply digital twins, which we did in the project, and our application was probably some 5 years ago. And at that point of time, there were still many projects which had a kind of reactive applications. So the potential user received a text message or an email, and then he had to react. And we said we want to change that, as I said, 5 years ago when we applied for the project, to a more proactive approach and automated approach. Another thing which was a bit challenging for us in the application phase was something which very much relates to what Arjen said this morning, because we said we want to have a user-focused approach. And for that purpose, we said we will start with a so-called co-creation steering group. In this co-creation steering group, we will have, especially from 3 demo sites, various users. We will have aggregators, we will have DSOs, we will have technology providers, but all of the tech partners will listen to the users, and they take the decision what kind of technologies do they want to have implemented in the project. And then we listen to the users and ask the tech partners to implement this kind of technology, which of course is a challenge, because in an EU project you have to outline what kind of technology will be implemented, but we cannot really say it because the user has a say. However, the application was accepted, and we basically said we have a portfolio of technologies that we could implement, but the user will have the final say. So maybe that's just kind of introduction to the general project context. We have a wide European coverage with some 15 partners from 7 different European countries, and we have demonstration sites in Austria, Finland, and Spain. If you look at the Sender system architecture, we follow certain reference architectures, and on the left-hand side we have the more consumer-centric approaches. On the right-hand side, the aggregator-related applications we can provide, and then in the lower hand side of the graph we outline certain technologies that we will use, like a hot water tank controller, home gateway, and so on. And what I would like to do now is basically focus on the concrete technological implementations that we did, and that was on the one hand, consumer digital twin from our Greek partner Paragon, and they basically use this digital twin in the first step in the aeronautic industry, in order to forecast and also support the balancing of long-haul flights all over the world. And then they applied this kind of technology also to the Sender project to forecast the occupancy rate of buildings, which is quite important, and quite important input factor also for other technologies in the project. And if you look at the two graphs, on the left-hand side you have the, let's say, a forecast of the occupancy rate based on the NX66, and on the right-hand side the digital twin, which is much more closer to the real occupancy of the buildings. Second core technology is from HYPERTECH in Greece, building as a battery. So in a way, the approach to use the thermal characteristics of a building in order to forecast, on the one hand, the occupation of buildings and the energy use, and then to optimize that. And I think third technology, which was very important for us in the project, is the so-called virtual lab and global integrated platform. So our experience before applying to Sender from other projects was that we try to implement technologies at the customer side, and then we understand there are interoperability issues of some solutions from different suppliers, and for that reason we said we first test everything. We test the interoperability of all solutions in a virtual lab. If that works, we go into a so-called integrated platform, and once we are completely sure that we can implement a solution which is really working on the customer side, then we will go for it. And to have this kind of approach, we developed this virtual lab and global integrated platform with the Austrian Institute of Technology. Then, as probably every project in this area has, the front-end application, which gives the user very detailed input on his consumption characteristics, but also on room conditions at his site, and also the ability here to steer certain devices based on this front-end application. If we look more at the left-hand side and the consumer part, we have on the one hand developed for the individual consumer a supply and demand forecasting tool that was done by CRS4 from Sardinia in Italy. And I think we have meanwhile some 3 or 4 academic publications on it. It's also able, this model, to have a kind of disaggregated load forecast if you don't have individual measurement data for each of the components. And the accuracy of this model is really excellent, and also a kind of scientific milestone and benchmark now in the academic discussion on the supply and demand forecasting. Minimizing the electricity bill, the same statement as we heard before. We applied smart water heating tanks from AXPO from Norway. They developed the technology further during the project, and now this technology allows to use the hot water tank according to the electricity spot market prices. And the steering of this technology is also integrated in the user interface. And as I heard before in the presentation, also here a huge impact on the energy consumption based on these hot water tanks, because in many countries they are the main electricity consumption appliance in the building, and therefore, I think really impressive results that we saw in this area. The smart charging EV energy management system from Trialog in France is applied at one demonstration site in Finland. And also here you see on the graphs on the right-hand side that based on this EV energy management system, we were able to have a much smoother load in the grid, and therefore also supported the DSO in Finland based on these smart charging solutions. And I think the final part that we developed for the consumer is basically the sender smart box. So that's basically the component where all the information from a household runs together, where the tech providers can access the data. And maybe interesting side remark, when we installed it in Finland, many customers were a bit embarrassed because it's black and everything else in the house is white. So that does not really fit into the interior design, but still the technology functionality is given, and therefore each user in the Sender project has this kind of smart box in the building to run all the Sender technologies.
1 minute. Sorry for that.
Aniol talked about the peer-to-peer trading system, and we did not actively apply it in the project because the regulatory environment and the restrictions were too hard to implement it. However, there is a GitHub site, and we further developed the technology solution, and therefore the basic code and the peer-to-peer trading solution from NTNU in Norway is further developed, and it's basically available on a special GitHub site without any restrictions. So if you want to use something like that as a base for other projects, that's, I think, perfectly fine. Finally, just 4 remarks. What kind of challenges and lessons learned did we have? On the one hand, the COVID challenge. Core problem for us, there were very motivated customers, and then they are waiting for a year or a year and a half for an implementation. So it was quite challenging to keep these activated customers engaged, motivated, and we tried to use some micro boards in order to have a kind of other non-social interaction with them. Then, as Aniol also said, the tech supply shortages, on the one hand, the raspberries and also other components which became first much more expensive, and then the delivery times were much longer than expected, and therefore we also had to face a project implementation delay due to these external factors. And finally, I think the on-site self-audit process was a bit difficult because not all the technical information that we required was really provided by the consumers, and therefore we had to have many site visits to really understand what kind of electrical installation is there, what kind of switchboards, and then to adjust our solution to it. And finally, the aggregator involvement, even if we talk about some 100 or 200 involved customers at certain sites, aggregators still tell you, yeah, that's household volume, that's not industrial volume, therefore not really a business case for us. Thank you.
Thank you. Okay, now we will jump to the next project, Accept. If Antonis, you can jump on.
Good morning from me as well. So I'll tell you a few things about the Accept project, a sister project of the previous two, also in the very, very late stages of project implementation. So we have until the end of the year to go. First, I'll tell you a few general things about the project, and then our idea here was to show a little bit of results just to motivate what can actually be achieved with what we're doing. So we started in 2021, a consortium of 16, if I remember correctly, and we have 4 pilot sites. So we have 1 in Spain, 1 in Greece, in Switzerland, and in the Netherlands, in Holland. Quite different pilot sites in terms of the available infrastructure, but also social, cultural backgrounds, and so on. Of course, if you like, again, 2 main pillars, technical and engagement, and there's always a battle between these. Now, in terms of what we started off to do, so maybe, this is an older version of the slide, so I'll go back in a minute. So in terms of what Accept started out to do, so Back then, there was this whole discussion of energy and non-energy services. These were the buzzwords in the days of the Commission, and if you like, our way to express that people most probably would not be interested purely in energy services, so you have to bundle them together with something they're actually interested in order to increase acceptance. And that was from the start, if you like, our perspective. So the other thing, the non-energy thing could be comfort, could be convenience, could be, for example, smart charging, have your car ready, indoor temperatures and indoor conditions that people like, and we can keep them as they like them with reduced energy consumption or helping the grid, the standard stories. So this was from the beginning our major concept. Now, of course, accessibility and benefits for the communities were critical. And of course, we wanted to somehow bundle this in viable business propositions, let's put it that way. So it has to make sense for the end user, for the community member, but it also has to make sense for the service provider. Otherwise, it cannot fly on its own, right? And it's a complex problem overall. And that's also why we're talking about business models for different roles, which again, I will not claim we're done yet, but this is, in the last phase of the project, this is where our focus is. So in a nutshell, we designed and we implemented digital tools to make communities basically act as service providers for their members, if you like. And some of the business scenarios we're looking in on the left side of the screen was, for instance, become an aggregator, a community to become an aggregator using these tools, as Christian was just mentioning, or become an energy service company offering energy management services. So this could go more into, I will manage your HVAC system, keeping for example, the indoor conditions at acceptable levels with SLAs or whatever, right? We also try to look a bit into P2P, peer-to-peer trading, also with, I would say, we didn't go so far into this for the reasons just stated. Another thing we wanted to do was look into if we could help communities act as retailers, in the sense that there's a use case that says if you have demand flexibility, you could use that to optimize your hedging towards prices in the wholesale market. So if you buy flexibility and you can affect your portfolio demand profile, right, you could buy from the wholesale market in a better way and then sell it to your community members. So these were from the start some, if you like, ambitious business cases we wanted to look at. Always, if you like, the backdrop or the background of this is that I can get some flexibility from demand sources or storage sources from my members, and I want to leverage them to do different things as a community. And yeah, as you see, we were a bit ambitious in the, if you like, the variety of services we wanted to look into. And of course, we didn't achieve everything. But again, this is a research project, so we are trying different things to see what actually works. And now on the right-hand side, you can see some more specific use cases about all of this. But what I'm going to do next is I want to show you 2 or 3 use cases and some of the results, if you like, the technology results we achieved. And then based on this, we are building, if you like, the impact assessment and also the business side of the story. So if we can actually achieve these results, how can we encapsulate this as a viable business proposition or model? So for example, this is a result for flexibility, forecasting, and activation, to be honest. So it goes a bit broader than the title. And if you like, our fundamental assumption behind all this is that we want to do this in an automated manner. So this is actually tools doing demand shifting in an automated way with as small as possible impact on the people, on their comfort, convenience, and so on. So maybe this is a real result. Of course, the results per se are not very impressive. But if you look at this, so on the top figure basically shows the demand profile, and it shows 2 activation peaks of the water heater, right? And the idea is, so this is the green part. Sorry, the red part. The red is the forecasted based on the past activation of the water heater. And then the idea is, if we can move these red peaks on the bottom, on the top curve, to the green peaks, then we can save in the beginning energy cost due to the price difference. So the blue curve is actually the price, which is I think this result comes from Spain, and then they have actually a real-time tariff per 15 minutes, if I'm not wrong, or per hour. Okay. So you can leverage this kind of dynamics. And then the bottom figure just shows the activation of the water heater automatically in line with what was forecasted in the top figure. And on the right side of the slide, you see some benefits. Now, this is the only thing that changed in that demand profile of the day for the specific household. This is 1 water heater. So from that, we can gain 6 cents, which is 3% of the, of the actual demand of the home for that day, right? And if you put it into, money figures, this is 6 cents. So it's not a lot, right? But this is only the water heater for 1 day for a home, and it works. Now, we received no complaint. That doesn't, leave us out of the bush yet. But this is something that actually worked in an automated way using these tools. And these are tools that we could, in principle, give to a community and say, now you can, go on your own and apply this. Another thing, another example of a result. This is about smart charging of an electric vehicle. Again, on the top left figure is basically the forecast of the baseline. The bottom figure is the optimized charging profile. But what is interesting here is that the use case, if you like, the end business case here was one of the DSO who wanted to reduce the peak power on the substation. And the top right figure basically is the power of the actual measured power on that substation. And what you see is that even by smart charging 1 vehicle, we could have a 6% peak load reduction, right? Again, this is an automated result using digital tools and so on. And of course, we're now in the process of replicating this thing in order to get the final project results, which should be much broader than just a single asset or a single household or whatever, and trying to find what is the real impact of doing all these things in a coordinated manner. This was basically time's running out. So this was a test of activating flexibility in an HVAC system in Switzerland. But this is a large HVAC system. It's a large heat pump on a building with about 30 apartments. Very small apartments. Let's put it that way, more like rooms. And this has a hot storage tank. So it's a large heat pump, storage tank, which gives you the possibility of thermal inertia. And then by controlling that, basically, you can shift the consumption of the heat pump around in time. So there, we were forecasting flexibility potential of 40 kilowatt. That's a single day. And we achieved about 15 of these without a noticeable difference in indoor conditions. Right? So this, again, gives you a perspective of, okay, of course, I can forecast very nice things, right? What am I able to actually achieve in the real world? But even that, again, this is a single asset. So this is promising in the sense that if you replicate this, you can amass some flexibility that's relevant for real-world use cases. Coming back to the discussion of the previous session, so end users were, let's say, quite happy. Not everybody was rooting for this, but we didn't get too much, if you like, pushback. So we are happy with that. And there are also some lessons learned, but there's not much time about this. So I think most of these were covered by the previous presentation by our colleagues from, explaining the user engagement story. But basically the idea is we have to talk to users a lot. I mean, you have to keep them in the loop very closely. You have to be very flexible. Things go wrong, and there's very limited time to get them right again. And you need basically to fine-tune everything. Every time, 4 different pilots, 4 different cases, 4 different approaches, socially, culturally, infrastructure, blah, blah, blah. So there's no, let's say, methodology that suits everything. So we have to be adaptive. So that's all from my side. Thank you very much.
Okay, thank you so much. I think we're going to have a
Move
look
on?
to the pilots, yes.
Perfect.
And after,
And the video is here.
yes, the video.
At the French pilot in the city of Palaiseau, south of Paris, maintaining engagement was a challenge
Is it okay for
as
the
the
sound?
project went through COVID and the biggest energy crisis in decades. So we maintained engagement with the participants with help of regular communications, newsletters, but also challenges and workshops. So for us, one of the key innovations and results of the project was the joint deployment of very fine-grained measuring equipments on the smart meters, but also appliances in the home, and a sociological assessment of the evolution of practices. As a result, we helped our participants to build awareness and habits on the consumption levels of their appliances and also on the time of use of these appliances. So as 2 of our participants said, becoming aware of peak hours and significantly limiting the use of the dryer were the big changes with HESTIA. And this explains my reduced consumption. Because before, I didn't work from home. And now I have computers and lights on, and consumption still went down. And another participant said, learning to shift usage, paying more attention, little things I wasn't doing before. I wasn't sure I could do more, and in the end, I did more.
I'm going to talk to you a little bit about our pilot site in Voorhout. It is a small community of 33 homes, half of them for seniors and half of them for families. And they are energy positive homes with built-in solar panels, heat pumps, and household batteries. There was a very ambitious project at the beginning, but due to technical difficulties, an immature supply chain, they had to scale down those ambitions. And as a result, also, I think the main innovations that we see in this pilot project are social and not technological in nature. I'll mention 2 here. One is that if you have a basis of a sufficiently efficient home and energy literate people, smart energy tech very quickly becomes dumb tech because people are actually smarter than the technology, and then it loses its purpose. Second one is that automation only is unburdening to people if it works. As soon as it does not work anymore, then actually people want to regain control either by manual control or by setting the rules of the algorithm themselves.
In HESTIA project, the first challenges was the citizen engagement, but in the end they were very amiable and willing to collaborate with us. We met a second hard task, that was the technical deployment in the pilot area of devices for data collection, transmission and storage. The wiring process of the Italian pilot area met some difficulties because of the morphology of the territory, the low C device connectivity, the not completely Wi-Fi availability, the tricky communication among software of hybrid energy system and smart meters, and the COVID too.
Performed experimental test. This test showed significant potential for energy savings and CO2 emission reduction when the heat pump is controlled by an intelligent algorithm.
I was curious about how we can use energy more efficient, so to lower the footprint.
I've been thinking about it. I don't want to be part of the problem, I want to be part of the solution.
The challenges related to the installation of the IoT equipment on site were faced mainly due to the very old infrastructure.
Empezamos a ver que había nuevas posibilidades de ahorro energético y eso también nos parecía interesante.
Bueno, pues están viendo un poco ahora hacia el final, ¿no? Y sobre todo, pues creo que es la semilla para más cosas que pueden venir, ¿no?
An issue that we introduce in the CIA performance, as it is this killer to switch on of the distilled water at the domestic use of our users. That could offer them the chance to store the energy in hot water in the lowest price of the day, which are also the moments the lowest price always mean that the energy is cleaner.
Principalmente aplicar todo esto y que se extienda más el tema de las comunidades energéticas.
There was too much information in it and I lost track. Well, but the little apparatus, the insight I got, I liked very much.
We found out that it was far too expensive to make the connection between the solution of the local vendor and the AXPO solution. So we quitted with this. It took a long time and we were very happy that we at the end could work directly with AXPO during the project.
Reilu vuosi sitten tehtiin kaupat tästä nykyisestä kämpästä, joka on sähkölämmitteinen asunto ja se oli aika lailla sitä niin kuin pahinta energiakriisiä siihen aikaan, että sähkön hinta oli kovasti kaikkien mielissä ja samalla lailla omassa mielessä. Sitten ystäväni Matin kautta törmäsin sitten tällaiseen VTT:n hankkeeseen, jossa tutkitaan sähkökulutusta kotitalouksissa. Ja se vaikutti mielenkiintoiselta hankkeelta, niin ilmoittauduin siihen mukaan ja onnekseni pääsin tällaiseen mielenkiintoiseen uuteen projektiin. Tosiaan tietysti tässä on nyt tämä aika, mitä ollaan asuttu, niin hyvin tarkkaan tullut seurattua oman huoneiston sähkönkulutusta, mutta nyt sitten odotukset oli tämän projektin myötä, että pääsis tavallaan tarkemmin selvittämään, että miten se sähkönkulutus jakaantuu tässä huoneiston sisällä. Ja sitten tietysti se, että ensin kun tietää, että missä kuluu sitä sähköä, niin se toinen toimenpide olisi sitten se, että pystyisi myös sitten ohjaamaan sitä kulutusta. Ja tietysti sitten se, että miten sitä ohjataan, niin saisi pörssisähkön mukaan ohjattua niille halvimmille tunneille. Oltiin aika lailla ensimmäisten joukossa tässä projektissa, keille asennukset tehtiin, mutta ne sujui kuitenkin tosi hyvin, että tietysti siinä vähän hakemista oli, kun ensimmäisten joukossa oltiin, mutta pääsääntöisesti hyvin, että ei mitään niin kuin suuria muutoksia jouduttu tekemään, että tosi huomaamattomasti nuo laitteet tuntuu olla. Meille asennettiin mittaukset tuohon sähköpääkeskukseen, eli meillä on nyt mittaus sekä tuolle ilmalämpöpumpulle että sitten makuuhuoneen lattialämmitykselle ja sitten myös koko huoneiston osalta tehty vielä niin kuin mittaus. Ja sen lisäksi meillä asennettiin tuonne Raspberry Pi-kone, mikä kommunikoi sitten tähän VTT-sovellukseen ja sitten meillä on myös erillinen ohjauslaite tuolle ilmalämpöpumpulle. Asennusten jälkeen me ollaan erillisen sovelluksen kautta pystytty seuraamaan näiden ilmalämpöpumpun ja sitten lattialämmityksen kulutuksia. Olen ollut kyllä tyytyväinen tähän mennessä projektiin, että ei ole tosiaan mitään ylimääräistä tullut itselle tässä, että lähinnä lisätietoa siitä, että miten nämä meidän laitteistot kuluttaa. Ja se on oikeastaan tullut yllätyksenä, että esimerkiksi kuinka tehokkaasti ilmalämpöpumppu lämmittää, että kuinka vähän se todellisuudessa viekin sitä sähköä. Että se on kyllä hyvinkin energiatehokas lämmitysmuoto. Tulevaisuudessa odotan varsinkin, kun sovellukset kehittyy, että näitä laitteistoja pystyy sitten hyödyntämään sillä lailla, että ne ohjautuu automaattisesti, että käyttäjän ei tarvitse tehdä mitään toimenpiteitä energiatehokkuuden edistämiseksi. Suosittelisin kyllä tällaista projektia muillekin, jos vaan tulee mahdollisuus osallistua. Että tämä on ollut itselleen ainakin hyvin vaivatonta ja yhteistyö tässä niin VTT:n kanssa on ollut sujunut hyvin ja paljon lisätietoa tarjonnut tästä oman huoneiston kulutuksesta tämä projekti. Ja toivottavasti sitten vastaisuudessa tai jatkossa on mahdollisuus myös sitten päästä sitä kulutusta ohjaamaan.
At the French
to join the panel for discussion. I assume all the presentation will be available, you know, that you can download after, so don't worry if you miss some information. So everything will be available, and I think it's recorded also, so by the way, you will have different opportunity to access information. And you have the contact of the project also by itself. So before opening the floor also to the audience, I will ask some questions to my colleagues, and after we'll have some additional opportunity. So maybe to go back, I will jump to the first presenters, to Matteo. I will ask you the question, can you share lesson learned from the pilots that you could guide the future energy management initiative? Can you share this kind of example and insight? I think it's working.
Okay, thank you very much. Now you can hear me. So thank you for the question. So we, based on the previous presentation, we already have some spot relating with the lesson learned. So I can speak about the HESTIA project. I'm with MIDAC, that is a company that produces energy storage system, and we develop energy storage system in the HESTIA project. And as you can see this morning, that HESTIA involved three pilots with different technology. We have a smart meter, energy storage system, and several other tools, as Federico of AXPO explained before. So we integrate with the project all these services, and I think the good results of the project is based on the competence and the effort that all the partners put on the project. By the way, I think we need to take care about some, let me say, details that need to improve to avoid waste of time and so on. It was mentioned before, the internet connection. Probably it seems something that it's quite easy. That so all the services start from a data that stay in database. So we think that this data is present in any way. So we don't take care about how the data is transferred. And so we went to the pilot, and we saw that it's happened that sometimes the connection is weak and the data is not transferred in the correct way. And sometimes we thought to use the household connection, that this household connection maybe is far from the where the, in my case, in case of the energy source system, where the energy source system installed, and this doesn't guarantee a good transfer of information. So I think in the writing proposal it's better to add a budget, for example, to have a dedicated internet connection to avoid this problem. Another important point that I want to mention is the installation and the service process. Usually in the research project we're gonna install system that is not standard system. Sometimes you need to have skilled people to install the system and to maintain the equipment running for all the project. So for example, we install a community battery in Netherlands, and so MIDAC is a big company. We have a subsidiary in Netherlands, so we can install and do services there. By the way, if we don't have a service locally, it's better to consider a budget for that, because it's not so easy from Italy, for example, to do services in Netherlands. And the last, but not least, is was mentioned before, is to listen the participant to improve the solution. So I remember that, for example, in Berkida, the one participant showed us that there was a little mistake in the control strategy of the energy storage system, and we cannot see this on the database, because we get the information every 50 minutes, And then they stay in front of energy storage system and look all the time how the systems works. And we discovered that it was a simple bug in the control strategy. So we added the 0 and then it create a different behavior of the system. So need to ask the participant and need to be present. It was mentioned with other people to collect all the information to improve the system. So this is the experience that I would like to share.
It's perfect. So I will ask Pablo if, on behalf of AXPO project, how do you see the innovation developed in the projects to influence the broader energy market in Europe?
Okay. What I believe Europe is pushing for, the development of energy communities. So we have found that, for instance, in Spain, we have some issues for that development. Some are due to regulation, and some are due to what it means financial. So what this kind of solution could provide, in one hand, could make the energy communities more sustainable because they offer ways to, really maximize PV production, maybe try to explore peer-to-peer, at least with collective PV plants, have a better sharing among the users. And also it has helped us to identify what the issues with the regulation. So we can put the focus on that and just try to, let's say, lobby for the EC to try to overcome these issues. Also, what is important is if we want these communities to be an active market player, we need to empower them. We need to really make them popular all over Europe so they really become an energy market player. And that's why I think we accomplish, the objectives of democratize the energy, empower citizens, and of course, make possible to implement more renewable energy sources, distributed energy resources. That I think is very linked with the directive objectives.
So it's perfect. And Christian, on behalf of Sander, it will be a technical question. So you base part of your project on dynamic pricing, and how do you protect consumer from high spot market price?
Yeah, I think we see a general tendency. If you look, for example, at the German electricity market, which is the biggest household electricity market in Europe, maybe you have an educated guess. We need smart meters for dynamic pricing. How many household consumers in Germany have a smart meter? Any idea? It's less than 1%. But from next year, there is an obligation of the government that electricity suppliers, they will have at least a variable price and later on also the dynamic pricing. So therefore, I think there's a huge opportunity also for the exploitation of projects like ours, because there are some untouched markets, like Germany, for example, where you could roll out these kind of solutions with demand response, flexibility, dynamic pricing. And let's say my background, coming back to your question, is from electricity trading. And if you do electricity trading, you know that there are also hedging options. So in order to avoid consumers from sky-high spot electricity prices, as we saw them by the beginning of the Ukraine conflict, you could buy for your consumption volume an option on a cap price, on a maximum price, and that would basically protect your consumers in your energy community or in your demand response projects.
Thank you for the question. I imagine we will have also comments from the audience, because it's touching some very sensitive point at the end, how we can transform this solution to be a wider market. It's really sensitive. So we have prepared some questions, and after I will open the floor. So going back to HESTIA, so I will ask you, what are the next steps HESTIA envision to bring its innovation to the market?
Yes. So from my point of view and from the project perspective, I think the HESTIA project brings a lot of benefits to the participant. So now the HESTIA consumption is moving in two directions. The first one is to sign an MOU. So we want to we signed this MOU to put our willingness to bring the solution to the market. The second one is to continue to develop the system. So, for example, MIDAC, we develop the solution, we improve the solution that we develop with the HESTIA project, and then we want to put on the market, and we have discussed with the partner of the project how to use the solution in the energy community.
So going to the answer. So going back to Pablo. So the second question we can ask you is how important is the rate tariff type in large DR scheme at European level?
I mean, this is very related what Christian
Absolutely.
said. I mean, at the end of the day, we want the DR's, solutions to be fully implemented for the users. They have to see real benefits. If they have fixed tariffs or they don't have smart meters, so they don't see how the energy is, their energy behavior. You cannot really apply, because at the end of the day, you only can go to the explicit demand response when the TSO or the DSO, ask for that, and you need like 1 megawatt to participate in that system. So it's not for the end users. So you have the option of the time of use. Okay, well, you can do it, but if you have index price, if you have dynamic tariffs, you have 24 hours, with each hour with a different price, so you have more opportunities, to really, have these flexibility options. So for me, that's mandatory. And I mean, I'm very surprised at what he said about Germany, because for once in Spain, we did it a long time ago. I mean, we started back in 2014 for the domestic users. They have the last resort tariff was index, and every retailer, I'm a retailer, I represent a retailer company, and they could offer dynamic tariffs. So we are kind of used to, and I think that's good for our pilots in Spain. And I think that in the Netherlands, they have started recently, also in Greece, but still slowly. But I think we must push for all Europe to have this type of tariff, at least have the option to go for them.
And so, Christian, about Sander, about the pilots in Austria, Finland, and Spain, in which region do you see, let's say, the main opportunity to expand the project solution?
Yeah, as I said before, which might not be surprising, I see a huge potential in Germany. We at Smart Innovation, we do not only do research projects, but also consulting. And if you see requests from companies in Germany regarding electricity price, entry into the electricity market, the very interesting thing for us is that it's not the traditional utilities, but that there are companies from very different business fields, very different background, which now want to enter into the electricity market, may it be with an own electricity price for customers, might be with tech solutions which are close to their current product portfolio, which is not related to electricity. So I think there is a quite huge potential, but also in countries like Norway, where Smart Innovation Norway is from, you see now first steps to use this dynamic pricing. There's one company, for example, called Future Home, but also in their case, very similar to Sender. The main activity is not the demand response and flexibility provision. That's mostly running in the background. The main aspect is to have fire and smoke detectors, which are directly connected to the firefighters, security cameras, and things like that. So I think markets are on the one hand even markets with established smart meters that we need for dynamic pricing, but from the product portfolio I would also consider additional services which are not purely electricity related to be very important to create a certain interest. And for me at that point of time it's still the time to come up with this kind of solution and publish it and install it in the market, because we still see very many island solutions which are related to smart home automation, to electricity, to EV charging. So a bundle of these solutions might be a very promising business model, which we also describe in the deliverables of the Sender project.
For the answer, so I will open the floor, but just before that, just keep in mind also, because when my colleagues present the market opportunity depending the countries, also look at the figure, how many energy community you have in different countries. And for example, even if we have a large opportunity in Germany, they are the first one in number of energy community. If we jump to France, for example, we are the lowest one at the EU level. If you jump to Spain, even if there are some opportunity, we have different projects in Spain on energy community. You don't have so much, let's say, energy communities. So just to say also, this is a mix of all these, let's say, pillars to be endorsed in project solution, which makes something to be happen. Otherwise, it will never work. For example, in France, we face a lot of difficulties about installing equipment. Why? Because of data sensitivity. Guys don't want, they don't want to share, they don't want to install whatever, and even if you control, it has to be out of the home, so it makes almost no sense. So just to say, it's really complex at the end, but the dynamic tariff and everything makes sense also. And I will open the floor, but just I will give one question overall to each of you, is the cost of effort. When we speak about energy communities and changing the patterns at all the stakeholders, who will be in position to make some efforts. So if it costs nothing and it's just a question of flexibility because you win something, wonderful, it's worked. But on the other side, about the cost of comfort, who will make the change? The cost of behaviors, the cost, the constraints on the grid and everything, who will be the ones to make the efforts to ease the process? And a consumer perspective is not so simple. In the previous roundtable, you were discussing about comfort, wonderful, but which comfort are you going to sacrifice to win something if you don't win, especially money? If there is a price indication, wonderful, it works, but sometimes it's not. It's just because you have a peak demand or whatever, something. And so if you connect to the demand versus the production in a renewable energy communities, which is more, let's say, constraining, because you need to fit your demand to the production, here the cost of, let's say, the cost of effort makes sense. But on broader energy community with a different, electric vehicles, storage, hydrogen, whatever, you can mix all these vectors. The cost of effort is quite sensitive. So this is also something we need to think about when we need to explain things to people, because at the end, somebody has to do efforts. It will not be cost-benefit all the time. So it's just part of my question. I don't know if it's a real question, but it's sensitive. So because we do so many projects on that, and all the times we face the same difficulties. If you win, wonderful. If you don't win, start to create complexity, at least at end user side. So if you have some question, ladies and gentlemen, yes, for sure.
Okay, well, people may move basically for two main reasons. The money and the clean energy. Those are the both things that people do really matter. Some people think more about clean energy, some people are more aware of money, but within Texas price you have both drivers go in the same way. I mean, we see it in Spain, we have many days in the central hours. The day we have the price in the market is 1 cent, 2 cents. I mean, it's really cheap. So the drivers are always the same. And if there is one issue that we should transfer to the European Commission is how important the dynamic tariffs are for Europe. I mean, the big companies, the large companies in Spain, which is very clear, they don't offer index tariffs. They offer fixed price because they offer security. You are not going to be surprised for the price. But when you explain people how the prices come to the market, I mean, if you have a fixed price, you are always paying more because the retailer is covering itself,
offering a larger price. So I won't have any problem if prices in the market go up. But that is something that the final user has to pay. So it's not only a question about the European projects, it's about the Commission, the role of the European Commission in spreading the word all through Europe, how important dynamic tariffs are. And it's something, for me, for us in Spain, we guess it's the most important thing. Most important than all the things we are thinking about, engagement, all this stuff. The dynamic tariffs is the main driver for clean energy and for lower prices for users. And it's our must to explain to the Commission that this is the keystone of the building.
I will take 2-3 yes comments, question, and like that you can have opportunity to answer globally. Yes. So even if sometimes it's not a question, but you can comment whatever. It's a discussion.
Yeah. Here maybe I will add that there is also the social aspect, which is a key driver for some of the users regarding peer-to-peer. Some of the users, they are willing to give away the energy to vulnerable families. And I have 2 questions. One, it's more techie one. It's during the implementation of the pilot and the monitoring devices. Do you have any preferences regarding radio frequency, ZigBee versus Wi-Fi components? Because we have like a discussion on our project about it. And the second one, it's for you, what is the best strategy to reduce the number of visits on those households?
So, okay. But, okay. So I don't know if I can remember. So please help me.
Okay. Jump to the answer first, and after I will ask some more questions.
Okay. Okay, regarding which technology? Okay, probably the easiest way is like using Wi-Fi. But then you have the issue that when the user changes the provider, you have to go to the place. So I really like the C-Wave, ZigBee stuff because it's all, once you connect it, it's there in the Raspberry Pi. If you are going to use a Raspberry Pi, Wi-Fi makes sense when you say, okay, don't go that way, just go straight to the cloud, and we, save the money of this gateway. That, for me, is okay. But if we are going to use a Raspberry Pi, for me, as a commissioner of the devices, it's easier to use this other radio frequency stuff. And how to reduce the visits, I mean, you have to explain the users. It's like try to communicate as much, try to tell them the importance of, okay, at least during the project period, try not to change the Wi-Fi settings, or maybe it would be nice that they could tell in advance so we could pass the next Wi-Fi settings to the Raspberry Pi before, losing the internet connection. I don't know.
Maybe I can bring my point of view about a manufacturing company. So we are producing something. So the Raspberry, I forgot the name, the Wi-Fi connection, the internet connection is for my point of view, is the only choice because all the devices start with this kind of connection. ZigBee is not something that you can find on the market. So at the end you need to add a Raspberry, but it's become something that is not at industrial level. It's something that is for project level. So from my point of view, it's better to use Wi-Fi instead of ZigBee, and to reduce the service visit, I think is quite impossible, let me say. Or if you find a solution, it's you need to patent the solution. Because, so for example, I remember in HESTIA, he had a storm in Berkida, and the SC device, the breaker, SC breaker, disconnect the energy storage system. And so the household doesn't know anything about electricity, so we need to send someone to turn on again. And so in the real world, there are a lot of different scenarios, and it's difficult to predict them.
To try and answer also.
Yeah, I think as Anjol is also from the Sender project, he directed his question to the two other projects. So in a way, I'm out of that, but I just would like to comment on the remark regarding the dynamic pricing and the obligation of the Commission to push that and force it. And as you said before, I completely share your opinion, because if you have low prices, that's usually the hours with the highest renewable generation. So if you consume at low prices, you also strengthen the integration of renewables in the grid. And I think we should also, in a way, widen the picture. We're looking at our demo sites, but if you look at European level, we had many new cables which were implemented during the previous years, for example, between Germany and Norway. And the initial idea was that Norway could be a kind of battery for Germany. So if there is a lot of wind power production or PV production that cannot be fed into the grid, we could export that to Norway, they store it, and then Germany uses the electricity once it requires it. That was a nice political vision. Unfortunately, the reality is completely different, because now negative prices from Germany are also exported to Norway, and we basically see the same or very similar price picture in Germany and Norway. Same thing in a less advanced process happens in France, and that's also due to the European market coupling, in order to have the cross-border capacities allocated in a kind of Pareto optimum, where everyone has the best result. And if you connect this aspect to forecasts for the German market, where they see an increase of hours with negative prices on the spot market for the next 3 years of 4 times, because more and more renewable energy generation, you will also see an export of negative electricity prices to many neighboring countries, which once more strengthens the argument we really need dynamic pricing to consume the electricity in these hours with negative pricing, and to have a higher grid integration of renewables.
Very interesting and sensitive topic, so I will give you the floor.
Yeah, thanks. So my question is a little bit relating to this idea of sufficiency, sorry. So this idea of what is enough, and especially as we have actually on the panel now some of the energy suppliers, I guess, of one of the pilots. So I was thinking, essentially, okay, we make consumption more flexible, we might maybe reduce it or make it more green to come from different sources of energy, but what about designing in this idea that we might actually need to consume less energy overall? How is that, how do you see that on the different perspectives, I guess, because obviously you represent, you know, companies that have a stake into providing energy. So is it, how about this idea of what is enough? Maybe we actually just need to change our consumption, but also in the way that maybe we don't need that much energy for things. Or is that something that you can see being part of, you know, future applications? Or because we still talk about, you know, how to consume more efficiently, how to make it cheap, but how about, you know, reducing it overall in terms of, yeah.
Okay. I mean, at the end of the day, if we are more efficient, we are going to consume less energy to do the same. Okay, so that's a goal. Also, the bad thing about the consumption itself is like you are using resources that are limited. If you are using renewable energy resources, it's kind of unlimited. So you have to go both ways. Of course, now we are building, creating appliances much more efficient. You can, okay, the huge difference is lighting. Now you don't really pay attention to the consumption of the lighting. And before that, it was like one bulb, like 50 or 100 watts. It was crazy. And now you have LEDs with 1, 5. So Of course, going that direction reduces a lot the consumption of the citizen, of the population, and when you apply flexibility, when you are moving to the periods where the production, the costs are really low, and they are mainly attached to renewable energy sources production. So at least you are reducing a lot the emissions. So of course, when we think about being efficient, it's not like, okay, I'm going to use a better washing machine. But it's also learning, okay, why I'm having this consumption at this time when I'm not at home. So, okay, of course, all these solutions make you realize, this hidden consumption that you can save because you are not producing anything. You are not using that energy for nothing. But maybe you left your appliance on without you knowing it. So you must, first I think must go against these things. Identify hidden loads, reduce the consumption because you are more efficient when doing the same things you do. And of course, applying flexibility because it's not only cheaper, but I think, in my opinion, it's better for the environment. And from the company perspective, of course, we are selling energy. That's our business. But if we only sell energy, we aren't going anywhere because we are really small. So we need to sell energy services. This is our goal. And efficiency, flexibility are energy services that can provide a real value to our customers. And of course, make a name for ourselves.
Maybe you can.
Otherwise, there is another question. You want? No, if you want, Matteo, you have opportunity.
So I just want to say that when you talk about reduce the energy consumption, so we can discuss what is the energy, so where this come from, because so for example in Italy we use gases to heat our house and so on. So now we are moving, we switch most of the consumption to the electricity. So I think in the next years we're gonna see an increase of the electricity consumption. Even we have a reduction of energy consumption globally. So I think in any case, the energy consumption, even we're gonna consume less energy, will be increased. This is my point of view.
Okay, so we are running almost at the end. So I will just take one question here. After we have also a question online, and after it will be the conclusion. Okay.
Thank you. This is more of a comment again. Just to bring back the discussion from earlier about intersectionality and gender dimensions to the choices people make in the services that they purchase. One illuminating conversation I had recently, there was a fear expressed about being locked back in to a lifestyle that they don't want. Say it was a woman I was speaking to saying, that a lot of the energy is produced, as we say, for renewable energy in the middle of the day. And that's kind of locking somebody in to having to do their washing at this, at certain times of the day. And I think that was an expression of fear. And I think maybe just as part of the dialogue with customers at an early stage, a useful way of that discussion maybe would be to offer other choices like P2P. So, okay, maybe I won't use that energy at this time of the day, but I'll share it with somebody else, that idea. So I think just introducing those conversations, I think would help a lot as well with the transition.
So. Okay, and just, try to answer.
Yeah, I mean, peer-to-peer is fundamental. I mean, because, for instance, in Spain, you can have collective PV plants that they share energy, but like kind of several individual PV plants. But if any individual has any leftovers, they cannot share the energy with someone else. So if you allow that, you don't only maximize this kind of PV plants, but also there are a lot of people with individual PV plants that could put in action those plans for the energy community, so everybody could benefit. So it's something that we are pushing for, really. And it's not something from the retailers, it's the DSOs.
We have also a question online. I will take just one on the different, let's say, the constraints thanks to the difference between the national regulation while doing a EU project. How did you manage it? So each of you smiling. I know the answer, but it's a question, so I share with you.
Yeah, we talked about peer-to-peer trading, and our solution, due to the regulation, was to skip it.
I mean, of course you have to consider that, but it could be also a learning point, because you learn from in one country they have this possibility, and then you could study how it could affect in your own country, and maybe push for them or lobby that, or at least simulate to see what could be the benefits. But it's always, you know, an issue, and you have to, try to balance what you can do in one country with what you can do in the other pilot. But I think it's a learning point for everyone.
Sure. So, for example, for the energy storage system, so there is a different liquid code in different countries. So you need to deal with that if you want to install a battery. In Italy, you need to follow a given grid code, and in Netherlands you have to certify with another grid code. So it's more complicated. I hope that in the future will be a true European community and you have the same rules. But right now, this is the situation.
Okay, so I think it's almost done for the round table. Just to make everybody smile, tomorrow we will have a project also presented here when there is transnational communities trading and exchanging energy. You will see it challenging, but very interesting, because I think it's part of the future. When you were speaking about the exchange, it has to be part of the future. It's just a bracket story. And just to say, maybe as a small conclusion, I'm not so sure it's a conclusion, but just to say, okay, we also quite insist a lot on the co-design process. And it could be a question, I don't know if we have time, but we can discuss here. So what will be the part of the co-design process to involve consumer in the peer-to-peer, in the different appliances, in the different systems, technologies, services, global approach, and as well as global energy demand perspective, and also the sufficiency, which is quite a different topic than the energy demand, but okay. So just to say the co-design process, for me, it's really challenging, because if we ask people to be involved in the design, probably they will not go to what we expect globally, which is a carbon abatement, which is an energy abatement, and which is 100% renewables, at least, okay, let's say, in bracket again, but the Commission expects 45% by 2050, which is really quite challenging in many projects to be produced by energy communities. So asking consumers somewhere to develop and to co-develop appliance or project makes sense, but what will be the reality of their commitments thanks to these large, let's say, global targets we have in mind, which is quite different than only an energy price perspective, which is most of the interest of consumers somewhere. So I'm not so, okay, if you're sure,
okay,
we have 2-3 minutes.
One.
So,
for
but
instance,
it's just also a question, comment.
Yeah, I mean, for our solution, for our citizen solution, okay, where the user has to introduce a scheduler for the domestic hot water tank. It was already mentioned in the video. So this way they feel more, you know, involved in our solution. So they are more, their willingness to participate is higher. So we can really, okay, go with that and start going for the flexibility. If they are really engaged with our solution, they are going to benefit more, and we are going to get more, you know, better KPIs, more reduction. So.
Yeah, I think what really made a difference in the Sender project was our co-creation approach, where we really put household consumers on the table. They had to express what they want to have, and that really motivated them. Now we are running to the end of the project, and we still have people from the demonstration site saying, now we have all this equipment here, can't we have another project? So to reuse it, to expand it, and that was a very positive sign for us that that really worked and people are really engaged in it. And regarding the broader picture, maybe I think this reduction of CO2 emissions is nothing that we can do on our own, but we need also to cooperate with the build industry. And in this context, we also see more and more initiatives which basically put together the electricity industry, the building industry, in order to create solutions which then can start up on a building stock which is already more sufficient, more energy efficient, and then our contributions could be even more valuable than they are today.
So I don't have so much stuff to add. I agree with the Christian. So we have to work together to improve the solution.
Thank you all, and maybe asking the Commission to do something is also, when you say asking the Commission to reinvent a new narrative, I will say, this is a word, on the energy transition, probably also we need to ask to be more, let's say, supporting about the decentralized approach of energy, which will be part of the answer also, because as soon as you decentralize, you can go up to the citizen level, and at the end, it's a new narrative about energy concern. But it's perspective, let's say. So thank you so much. It was interesting. I hope you enjoyed, and we can discuss having lunch. Thank you.